Hi guys, this is Weasel for PokerBrainiacs.com. We are going to be discussing the topic of fold equity. What is fold equity? The definition of fold equity is additional equity in a hand given that your opponent may sometimes fold. Exactly how much fold equity we have is going to be an estimate, and it's going to be an estimate based on various things such as villain's range, some of villain's tendencies, and we will consider these later in the video. At any point where we want to calculate our total equity in a hand, we are going to need to consider both our pot equity and our fold equity. One limitation of tracking software such as Holder Manager and Poker Tracker and the all-in Eevee is that they only consider pot equity and not fold equity. To get a true idea of your expected value, you need to take both of these into consideration. There are some exceptions. For example, in the case of pure bluffs, you don't need to consider pot equity, only your fold equity. And in the case of hero being the one making the call rather than the one doing the betting, the only relevant factor is going to be pot equity. You only have fold equity if you are the one doing the betting and there is a chance that your opponent may fold. In some cases, fold equity is going to be an unwanted thing. Most of the time it's useful, but in the case that hero is making a value bet, fold equity is not necessarily something hero wants. And the reason is that it limits the calling range of our opponent. So we may have a strong made hand and we want to bet for value, but if our opponent is folding a huge amount of worse hands, it is going to be a lot harder for hero to extract a good amount of value on average. So when we are value betting, fold equity is not a good thing. Let's look at some examples of calculating hero's expected value using fold equity. In this example, hero is on the river and there is 100 big blinds in the pot. Let's assume that hero has no equity in the hand, so he has 5 high, for example, and he knows he can never win at showdown value, but he wants to make a bluff at this 100 big blind pot. Let's assume that hero fires a river bet of 80 big blinds into the 100 big blind pot. He estimates that villain will fold 50% of the time. What is hero's EV? If you want to pause the video and take a shot at calculating this, then feel free. In order to calculate hero's EV in this spot, we are going to need to know the basic formula for calculating EV. And it's a very useful formula, also a very simple formula, one that it is a good idea to remember. And it says this: expected value can be calculated by the amount hero can win multiplied by the percent chance hero has of winning, and subtract from that the lose amount, the amount hero can lose, multiplied by the percent chance of hero losing. And if you calculate this, you will find your expected value. So let's try and find the relevant numbers we need to put into this formula. The amount that hero can potentially win is the amount that is already in the pot that he's hoping to steal, 100 big blinds. The percent chance of hero winning, and in this case winning is going to be defined as taking down the pot, that is going to occur 50% of the time when villain folds. The amount hero can lose is the amount he is investing into this river bluff. So hero can potentially lose 80 big blinds in this situation, and he is going to lose those 80 big blinds 50% of the time when villain calls. Let's input those numbers into the Evie formula, and we get this. So 100, our win amount, times by 0.5, the percent chance of winning. Notice that we have to convert our 50% into a decimal in order to use it in this equation. 100 times 0.5, subtract from that the amount Hero can lose times by 0.5, that should say, and the resultant calculation is going to be 50 minus 40, and that is going to give us 10 big blinds as a result. So this means that every time Hero makes this river bluff, he is going to make 10 big blinds on average. So despite the fact that Hero has 0 pot equity, this play is going to be profitable. So hopefully we can see in this spot the value of fold equity. Hero has no shot at winning the pot if he checks it down, but this play is still going to be profitable. Let's look at another example. Hero raises to 3 big blinds on the button. This is going to be a simple blind steal. And in terms of how often the blinds fold, the small blind is going to be folding 85% of the time to an open raise, and the big blind is going to be folding 80% of the time. So reasonably tight blinds. Again, the question we want to ask is, what is the EV of this blind steal, assuming that Hero gives up when called? So in this case, we are not interested in Hero's pot equity. We are not interested in the hand Hero has. If Hero does get called, we are just going to assume that he automatically loses post-flop and he's going to give up when called. We are only interested in the expected value of this blind steal. So we are only going to be using fold equity and not pot equity. Again, if you think you know how to calculate this, feel free to pause the video and have a go at working it out. Just to remind ourselves of our Evie formula, and we are now going to establish the 4 different numbers we need to put into this formula. Our win amount is going to be 1.5 big blinds, because this is the amount Hero can potentially win. That's 1 big blind invested by the big blind and 0.5 of the big blind invested by the small blind. And the amount Hero can lose, in inverted commas, assuming he gives up post flop, is 3 big blinds, because this is the amount he is investing in his open raise. The question, however, is what is the percent chance of winning and what is the percent chance of losing? And in order to calculate this, we are going to need to know the combined amount of times that both the small blind and the big blind fold. As a general rule of probability, if we want to find the probability of 2 simultaneous events occurring, i.e. one event and another event occurs, we need to multiply the respective probabilities of the individual events occurring. In this case, we know that we want the small blind to fold and the big blind to fold. We are going to multiply the respective probabilities of these 2 events happening. So we have 0.85, which is a decimal format, multiplied by 0.8, and that gives us a total of 0.68. We can see then that the probability of both blinds folding and Hero's blind steal being a success is 68%. We can therefore calculate that Hero's chance of losing is going to be 1 minus that amount. So Hero is going to lose 32% of the time, where losing means that Hero is going to get called or re-raised, etc. We now have our 4 numbers to put into our Evie formula. So if we input those numbers, we multiply out the brackets, and we are going to see that we get the result of 0.06 big blinds. What this means is that Hero is going to make a profit of 0.06 big blinds per blind steal, even if he never c-bets. And of course, Hero will sometimes be c-betting. Even if Hero is a very tight c-better, he is more than likely going to be c-betting if he flops a strong made hand, perhaps 2-pair or better. So Hero's EV for making this blind steal is going to be a lot higher than 0.06 big blinds. But Assuming that hero is never going to c-bet, he can still make a small profit open raising from the button against these two tight blinds. Even if he just open raises any two cards, he is going to make an automatic profit. So hopefully we can see the value of fold equity in this particular scenario, especially the case where hero is in a steal position, perhaps the button, maybe the cutoff, and the blinds are very tight. Hero quite often may even have a profitable blind steal by opening any two cards just as a result of the fold equity that he has. Let's look at a third example. This example is going to be a little bit more complicated, and we are going to factor in hero's pot equity also in this particular case. And pot equity is going to be calculated in the same way as we've calculated our fold equity, using the expected value formula. And this is the scenario. Hero is out of position on the turn. Hero has the 7 of diamonds, the 8 of diamonds, and the board is the Queen of diamonds, the 5 of diamonds, the 3 of spades, and the 2 of hearts. So hero has 8 high with a flush draw. We are going to say that there is 100 big blinds in the pot and that there are 80 big blinds effective stacks remaining. The first question we are going to ask is, what is hero's expected value for check calling an 80 big blind bet, assuming villain has any type of queen, roughly 80% equity? And if we just open up a copy of Poker Stove, we can see on this board that I've literally, well, I'm going to make sure that villain has got any queen. So some of these queens will be two pair combinations, and it doesn't necessarily matter how realistic it is that villain is going to have this exact range. It is just for the sake of the example, and we can see that against that range hero has roughly 20%. We'll say he has 20% for simplicity's sake, which means of course that villain is going to have 80% pot equity in this case. So we're not interested in fold equity in this particular example because hero is going to be calling and therefore hero has no fold equity. Again, if you think you know the answer to this using the Evie formula on the previous page, then feel free to pause the video and calculate the answer to this question. Okay, so we are going to input some numbers into our Evie formula. The first is the amount hero can win, and the amount hero can win is going to be the 100 big blinds in the pot plus the 80 big blinds that villain is going to bet, the amount that hero is check calling. So hero can potentially win 180 big blinds. Multiply this by the percent chance of winning, and we've established that hero has 20% equity with his flush draw against any type of queen. We are going to subtract from this bracket the amount hero can lose, and hero can potentially lose 80 big blinds because this is the amount he is check calling, and this is going to happen 80% of the time. So we've input these four numbers into our Evie formula. We then multiply the brackets out, and we end up with 36 minus 64, which gives us a grand total of negative 28, which means that hero is going to be losing 28 big blinds on average making this call. So his expected value is minus 28 big blinds. In other words, hero is going to be making a loss in the long run by check calling in this particular situation. Let's imagine now that hero is not going to check call, but hero is going to bet the 80 big blinds into the 100 big blind pot, and he is going to assume that villain folds 50% of his Queen X hands. And we've done the example in this particular way for a reason. If we now modify the Queen X hand we think villain's folding, well, he's obviously not going to be folding anything that has two pair, so he's obviously not folding Queen 5, Queen 3, Queen 2 if he has those. But if we say he's folding the lower end of his Queen X hands, which don't have two pair, and say he's continuing now with this range, so the rest of his Queen X hands he decides that they are not good enough to call a bet, we can see that against this range that Hero still has roughly 20% equity. And the reason I've done it like this is because in some cases Hero is not going to have the same amount of equity against villain's calling range as he will against villain's betting range. In actual fact, they may even be quite a lot different, but in this particular example we can say that Hero has the same amount of equity against villain's calling range as he does against villain's betting range. Just to remind ourselves of the question, what is Hero's expected value for betting 80 big blinds into the 100 big blind pot, assuming villain folds 50% of his Queen X hands and therefore has 80% equity still? If you think you know how to work this out and you know the answer, feel free to pause the video and try and calculate the answer to this question. The easiest way of approaching this problem is to visualize every possible outcome with this flowchart. We can see that there are three possible outcomes to this situation. Either Hero bets and 50% of the time villain folds, or villain calls and villain goes on to win 80% of the time, or villain calls and Hero sucks out and villain loses, and this occurs 20% of the time. We can then go on to calculate the overall probability of the time that each of these events occurs. And as discussed, when we want to know the probability of two simultaneous events occurring, we multiply the respective probabilities. Therefore, the overall amount of the time that villain wins is going to be calculated by the percent chance of villain calling, which is 0.5, times by the percent chance of villain's hand holding up, which is 0.8. Therefore, villain is going to win in this scenario 40% of the time. Then the scenario where villain calls and loses is going to happen 0.5 times by 0.2% of the time, which gives us a grand total of 10% of the time. When we want to know the probability of one event or another event occurring in probability, typically we add the probabilities together. We are going to use a modified version of our Evie formula by adding together the occurrences where Hero wins on one side of the formula and subtracting from that the times when Hero loses. Our Evie formula then looks like something like this. On the left hand side of the formula we are going to add together the two instances that Hero wins. Firstly, Hero can bet 80 big blinds and he is then going to take the pot down immediately 50% of the time. Therefore the amount Hero can win is 100 big blinds, the amount in the pot, and we multiply this by 0.5, the percentage of time villain folds. We then add to this the other way that Hero can win the pot, and this is when villain calls and Hero sucks out. And in this instant, Hero is going to win 180 big blinds, and as calculated, this is going to happen 10% of the time. We are then going to subtract from this the occurrences where Hero loses, and we've seen that there is one possible scenario where this happens, when Hero bets, villain calls, and his hand holds up. And in this case, the amount Hero can lose is the amount he invested in his bet. And we know that villain is going to win 80% of the time in this occurrence, and the overall amount of times this happens is going to be 40% of the time. We then multiply out the brackets and we get 50 plus 18 minus 32, which gives us 36 big blinds. Therefore, hero makes 36 big blinds on average every time he makes this play. Hopefully we can see what a huge difference having a decent amount of fold equity makes. The cards are the same, the equity is the same, but in this second instance the hand is quite profitable for hero, whereas in the first instance where hero was check calling, the hand is unprofitable. This is a key reason why aggression is often going to be a winning tactic in poker. The fold equity you have is enough to, on many occasions, transform an unprofitable situation into a profitable one. There is a slightly easier way of calculating this, given that we'd already established the expected value of hero when he check called, and we know that he had a expected value of -28 in this occurrence. Perhaps some of you who were calculating the answer to this may have realized that we can in fact have as our loss bracket the fact that we are going to lose 28 big blinds on average from the point onwards where we are all in against villain's range, which has 80% equity against hero's 20%. And that this is going to occur 50% of the time, the 50% of the time when villain doesn't fold. And we can then use this as our loss bracket and calculate 50 minus 14 equals 36 big blinds. Therefore, given that we already knew the expected value of getting all in with 20% equity with the amount of money in the middle, we can then use this as a slightly simplified calculation to establish our EV in this situation. Of course, it's all very well knowing how we can calculate our expected value, given that we know our villain is folding a certain percentage of the time, but how do we estimate our fold equity in the first place? And of course, it is just that, an estimate, and it's based on villain's tendencies. We can ask various questions about villain. Is villain a nit? If villain is a nit, then he is going to be folding all but the strongest of hands, which means that you are going to have a lot of fold equity, which is very good if you are bluffing or semi-bluffing, but maybe not so good if you are trying to extract thin value, because a nit is just going to be folding the worst hands that you want to extract value from. Is villain a calling station? If villain is a calling station, he is not going to be folding very often, therefore your fold equity is going to be very low. This is very good if you want to extract value. You can fire all types of hands, all sorts of hands for very thin value, but it's not really so good if you want your opponent to fold. Therefore, in many cases, if you are playing against a calling station, you can even disregard your fold equity to a large extent just because you think that villain is never folding. And way more important becomes your pot equity and extracting value from villain. Is villain bluffy? Perhaps villain doesn't necessarily call light, but he's more than happy to put in a decent amount of bluff raises, especially if he thinks you are light. While he's not directly calling, this of course diminishes the amount of fold equity you are going to have, because it's more likely that villain is going to not fold and instead make bluff raises. Is villain a good hand reader? And the better villain is at hand reading, the more he is going to realize in situations where hero is representing strength. Whereas if he's not necessarily a good hand reader, then he is more going to be thinking about his own hands. Therefore, just because hero may be betting in a spot where it's unlikely that he's bluffing, maybe a villain is just not aware of that and he is going to call anyway. Sometimes you have more fold equity against a good hand reader, but conversely, if it's a spot where villain expects you to be bluffing, or perhaps there are very few value combos in your range, then it's a spot where against a good player you are going to have less fold equity. Therefore, to an extent, you need to be thinking about villain and his perception of hero's range if he's a good villain. If he's maybe not such a good villain, not such a good hand reader, perhaps you need to just think more about his range and whether that range is strong. Obviously, if someone has a weak range, you are going to have more fold equity in general, whereas if they have a very strong range, you can't expect them to fold anywhere near as often. Just to reiterate, fold equity is very useful when you are bluffing or semi-bluffing and you want your opponent to fold, but fold equity is not a good thing when you are betting for value. In some cases, you may need to not bet. You may want to underrepresent your hand by checking certain streets, or perhaps even hoping to induce bluffs from villain and take a line where you check call, especially if you know villain is quite tight and your value bet is going to be extremely thin because it's unlikely villain is going to be betting. It's going to be calling even with worse hands than yours. It may be a good spot where you want to use your hand as a bluff catcher and check call, rather than trying to go for thin value in a situation where you have too much fold equity for your value bet to be profitable. I hope this has been a useful introduction to fold equity. This has been Weasel for PokerBrainiacs.com. Thanks for watching.